inductors. AK, what does AKA stand for? AKA stands for also known as. They're also known as coils, or also known as chokes. Inductors, aka coils or chokes. And then they're shown symbolically, like so, or they could also be shown symbolically, like so. And when you have them in series, the symbol is L, so L1, L2, and L3. And the units are in henries. So let's say this is 30 millihenries. This is 50 millihenries. And let's say this is 125 millihenries. And so if we have these three that are in series, the total, your LT is equal to L1 plus L2 plus L3, just like resistors in series. And so when we grab these, this is 80, so it looks like 205 millihenries, yes? Everybody okay with that? And then in parallel, would look like this. L1, L2, L3, and let's say I have 100 millihenries. Let's say I have 50 millihenries, and let's say over here I happen to have 100 millihenries. So in parallel, your LT, you would use your reciprocal formula. 1 over L1 plus 1 over L2 plus 1 over L3. So there's your reciprocal formula. Just like reciprocal resistance formula or reciprocal capacitance formula, reciprocal is very simply this. So if you use reciprocal formula, the way you pop these numbers into your calculator would be 100 exponent, change sign, or negative 3, and then you hit your wonderful reciprocal key. You hit plus, then your next value of 50 exponent, negative, change sign 3, and you hit your reciprocal key again. You hit plus, and then you hit your third value, 100 exponent, negative 3. You should try this on your calculator as I'm doing this, because I'm going to ask for a number in a moment. And then at the end of the process, you hit reciprocal one more time, and you hit equals one last time. So when you go through this particular process, question then goes to, let me get my mouse here. Let's move this guy up here and go into grid mode. Close this guy. Close this guy out. Okay, so in grid mode, so Rolando, what do you calculate this to be?
Give me one second.
What's the total using the sequence of steps for parallel? We already calculated the total for series. Now I'm looking for the total in parallel. Do you have that value?
Yes, 25 henries.
What are my units?
In henries?
Yes, but is there an engineering prefix in front of henries?
Yeah, I
Is
got
it kilo
25.
henries? Is it mega henries? Is it micro henries? Is there some kind of prefix there?
Uh, I need to redo it again. A
No,
calculation.
okay, then take off your mic. Yeah, just mute your mic for a moment. And Andrew, do you have this?
Yes, I do.
What do you have?
25 millihenries.
Okay. If we're starting off with millihenries, as we are here, very likely you're going to end up with millihenries. So, like parallel, if you look at these, if I have inductors, if I have resistors in parallel, the total must be less than the lowest branch. What is my lowest branch of these three? My lowest branch of these three is 50 millihenries. So coils like resistors in parallel calculate the same way. My total for this must be less than the lowest branch. And the lowest branch being 50, it's got to be lower than 50. So you calculated 25, and it is millihenries. And so what's very important here is don't forget to enter your exponent negative threes, because if you're starting with milli, you don't just punch in 100 reciprocal plus 50 reciprocal plus 100 reciprocal. That would be incorrect. It has to be 100 exponent negative 3, then reciprocal, then add to the next line 50 exponent negative 3 reciprocal plus 100 exponent negative 3 reciprocal equals reciprocal one more time equals, you will end up with 25 millihenries, which would be correct. Now, because these are in parallel, we can always rely on reciprocal formula. Yeah? Reciprocal formula. But the other shortcuts also apply. Did you happen to notice the values I happen to pick? I have a 100 and a 100. Well, if I have 100 parallel to 100 millihenries, don't I have two of the same value? And if I have two of the same value, can I simply take that value and divide by the number of coils that have that value? So this can simplify into this circuit where I have an LEQ1, where 100 parallel to 100 would result in 50 millihenries. And I also have an original let's say L2. My L2 was 50 millihenries. So the L1 and L3 were parallel with each other. So this LEQ number 1 is equal to L1 in parallel with L3. And that's what gave us the 50 millihenries. Now, if you look at this one, can this be redrawn into a single coil? And the single coil will be identified as L total. And here I have 50 millihenries parallel to 50 millihenries. I can use the shortcut again. I can use reciprocal formula. I can use product over sum, or I can just simply use, anytime I have multiple identical value components in parallel, I can simply resolve their total by taking that number, which is identical, 50 millihenries in this case, divide by the number that have 50 millihenries, which is 2. That means this will resolve to be 25 millihenries. Are we okay with that? Any questions on that? Okay.